Okay, so sorry I can't be there with you today to explain horizontal asymptotes, but I do want you to take some notes today. So these notes should be located on my desk. They will look just like what you see here. And we've been talking about vertical asymptotes and holes, and we must talk about horizontal asymptotes just so this all fits together in the big scheme of things. So, but before I do, I want to just talk to you about horizontal asymptotes. Is all about the degree of the ratio. So when we have, whoops, let me change my color. When we have a polynomial function, a rational function with polynomials in the numerator and denominator, such as x squared over x plus 1. If you recall, the degree of a polynomial is always the highest exponent. So in this case, it's 2, and in the denominator's case, it is 1. And so horizontal asymptotes kind of base their whole universe around the relationship of the degrees of the numerator and denominator. Now I'm going to show you several examples. So let's take a look here. You see I have divided this into 3 sections, and I want to decipher what some of this wording means. First of all, this says if the degree of the numerator is greater than the degree of the denominator. You can see I didn't want to write out the words numerator and denominator, so I shortcutted it. Is that a word? I don't know. But at any rate, that's what that means. So if the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. Now there is a little mnemonic device to go along with this. If the degree is bigger on top, there is none or there is no horizontal asymptote. What about that? You're impressed, aren't you? That's going to make you all remember that there's no horizontal asymptote when it's bigger on top. Okay, let's move on to the second one. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always the line y equals 0. And let me point out once again, y equals 0 is, the y part is as much a part of the answer as the 0. Okay, so what this is saying is if the numerator is smaller than the degree of the denominator, then the horizontal asymptote is the line y equals 0. Here's the mnemonic. If the degree is bigger on the bottom, it's y equals 0. And then finally, if there's a tie, if the degree of the numerator and denominator are the same, then the horizontal asymptote is going to be created by the ratio formed by the leading coefficients. This can be a little confusing, so I'm going to show you some examples. But here's the mnemonic device that goes along with it. Exponents are the same, divide the coefficients. So let me go back and take a look. Take a look at what that simply means. Let me erase all this stuff. All right, so what that is saying is that if we have a tie, and I'm just going to put 3x to the 4th plus 2 over 2x to the 4th minus 1. And I am noticing here that I have a tie between my leading coefficients. Then what that, between my degrees. Then what that simply means is that the horizontal asymptote is going to occur. Watch the magic here. It's going to occur. Where's it going to occur? Where's it going to occur? There it is. The ratio of the leading coefficients. And of course I just have to tag on that y equals. So let me show you one more, because I know you're just fascinated by that. If we had, let's see, 2x plus 5x cubed over negative x cubed minus 1. Okay, so you can see once again, and again I try to switch the order around, try to make it a little tricky. So the degrees are the same. The leading coefficient always precedes these degreed terms, these highest degreed terms. So when the degrees are equal, then it's the ratio of the leading coefficients. So let me take out the magic eraser again. Here we go. Here we go. Here we go. All right. And what is missing is that understood 1. So when I kind of line these things up, I get negative 5, and of course I want it to be y equals negative 5. All right, so let's run through some examples. Let me back this up. So the first example is the degree of the numerator is bigger than the degree of the denominator. Well, then there is no horizontal asymptote. And here's the picture. And you can tell from the picture that there is no horizontal line that the graph is approaching. There's a vertical line. We can see that vertical line. We know how these graphs like to travel alongside the vertical asymptotes. Same is true for horizontal asymptotes, but you don't see a portion of this graph riding out horizontally. All right, so that's that. Let's take a look at the next one. If the degree is less than the degree of the denominator, so here's an example. The degree of the numerator is 1, the degree of the denominator is 2, then the horizontal asymptote is going to be at y equals 0. Now something really interesting happens here. There's the horizontal line, y equals 0. Unlike vertical asymptotes you can never cross through ever because it creates that undefined fraction at those vertical points. So, but you'll notice over here that this graph actually did cut through that horizontal line slightly. Just wanted to make you aware of the fact that horizontal asymptotes are a little bit, they sometimes allow special treatment. They let some numbers cross over the border, so to speak. Whereas over here, we can see that this graph is traveling alongside that horizontal asymptote, and it will never touch or cross over. So that's a little lesson on horizontal asymptotes. They do allow things to cross over occasionally. All right. And then the third example is when we have a tie. And here is what we're going to do. We're going to divide those coefficients. So y equals negative 5. There's y equals negative 5. And you can clearly see that those graphs are approaching y equals negative 5. So that kind of wraps up horizontal asymptotes and what they do. Now, at some point we're going to have to put all this together. We're going to have to put vertical asymptotes, holes, and horizontal asymptotes all in one mix, and you're going to have to figure out where each of those are. So just be ready. For the time being, get these notes jotted down, and I'll see you in class tomorrow.